in this lesson, we will learn how to derive the equation for range in projectile motion. Here is the projectile projected at an angle theta with an initial velocity of vi. As the projectile approaches at the maximum height, it loses its velocity. That means its velocity becomes 0, and then it starts coming down. Okay, and then reaches the initial position. Therefore, the y direction displacement is 0. How much height it goes in the y direction, the same amount of displacement happens in the downward direction also. Therefore, I wrote delta y is equal to 0. Next comes the velocity is at an angle theta. That is why I am resolving the velocity, as velocity is a vector. I am resolving the velocity into horizontal component and vertical component. And horizontal component velocity is VIY is VI cos theta, because this is cos theta adjacent side to that theta. That is why this is VI cos theta. This is the horizontal component. And then the vertical component is VI sin theta. Okay. Or if you want, I will write that also here. This is equal to VIY. And this is equal to VIX. Okay. Now, we have to find out the range. Range is velocity times, range is nothing but horizontal displacement. Horizontal displacement is equal to horizontal velocity times time. Okay, time of flight. Now, horizontal velocity is known to us, VA cos theta, but time we don't know. We have to derive the time from the kinematic equation. Delta y is equal to VIT plus half AT square. Here it is the y direction, so I am writing VI, I am taking the VIY, and VIY is VI sin theta. Therefore, and delta y is equal to 0. I already explained. So delta y is equal to 0. I am substituting the values. 0 is equal to VI sin theta t plus half. G is minus g. Acceleration is minus g. I am taking negative g. And then because it is coming down, and then in both the sides, I am taking a acceleration as negative. Okay. So a is equal to minus g. And then substituting that in the equation, I get 0 is equal to VI sin theta t plus half minus gt square. Now simplifying this one, half gt square is equal to VI sin theta t, or t is equal to 2 VI sin theta over g. This is the value for t. Now I substitute this t value in the range equation, and that will become VI cos theta times 2 VI sin theta over g. Now rearranging the equation, I get VI square 2 sin theta cos theta by g. And we know 2 sin theta cos theta is equal to sin 2 theta from trigonometry. So R is equal to VI square sin 2 theta by g. This is how I got the range equation. If you remember this one, this can be used in many ways in the projectile motion. It will become very easy for you. Thank you. Bye-bye.